let's do some exercise. Okay, let the first one be finding the distance between 2 points in 3D. Okay, let's say point A is equal to -1, 1, 0, and point B is equal to 3, 0, -2. Okay, now AB magnitude is equal to 3 minus minus 1. So 3 minus minus 1 is 3 plus 1. 4, 4 square, that is 16, plus 0 minus 1 is minus 1 square is 1, plus minus 2 minus 0. So minus 2 square is 4, which is equal to 16 plus 4, 20, 21. A is equal to 2 minus 2, 3, 5, and B is equal to 1, 2, 3. Now magnitude of AB is going to be 1 minus minus 2. So 3 square is 9, plus 2 minus 3 is minus 1. Minus 1 square is 1, plus 3 minus 5 is minus 2. Minus 2 square is 4. 9 plus 4, 13, plus 1, 14. So the distance is square root of 14 units, whatever it is. Okay. Now what we have to do is, let's say we are given 3 points. A, 3, 2, -4. B, 9, 8, -10. C, 5, 4, -6. Now what we have to do is we have to show that these 3 points are collinear. So if these 3 are the points, we have to prove that they lie on the same line. Now how do we do that? If you see, if I take the distance here and the distance here, if I add them up, I should get the distance between these 2 points, right? So let's figure out the distances. So AB is equal to square root of 9 minus 3 is 6 square is 36, plus 8 minus 2 is 6, 36, plus minus 10 minus minus 4, that is minus 10 plus 4 is minus 6 is 36, which is equal to 108, which is equal to 1082542273933. So 236 root 3. Okay, now let's figure out BC. Okay, now this would be 5 minus 9, minus 4, minus 4, 16. 4 minus 8, minus 4, plus 16. Then we will have minus 6 plus 10. Minus 6 plus 10 is 10 minus 6, 4, plus 16 is 16, 3 is 48. So 4 root 3. Okay, now let's figure out AC. Now AC would be 5 minus 3, 2 square is 4, plus 4 minus 2 is 2 square, 4, plus minus 6 plus 4 is minus 2 square is 4. This gives us 12, which is equal to 4 times 3, that is 2 root 3. Okay, so if you notice now that AB is equal to AC plus BC. So therefore they are collinear, right? Okay. Now what we have to do is show that the point I plus 3j plus 4k is equidistant from 3 comma 2 comma 2 and minus 1 comma 1 comma 3. Now what do we do? Let's imagine that this jk point is this. Now what we have to do is we have to prove, let's say this is A, this is B, and this is C, right? So let's say this is A, B, and C. Now what we have to prove is that this and this are equal, right? So basically, which means AC and BC should be equal, right? Now let's figure out C. The in the coordinate form, it would be 1 comma 3 comma 4. A would be A is 3 comma 2 comma 2 and B is minus 1 comma 1 comma 3. AC is square root of 1 minus 3, 2 minus 2 square is 4 plus 3 minus 2 is 1 plus 4 minus 2 is 2 square is 4, which gives us 4 plus 4 8 plus 4 9, which is 3. Okay, now let's figure out BC. Now BC would be square root of 1 minus minus 1, so 2 4 plus 3 minus 1. 3 minus 1 is 2 square is 4 plus 4 minus 3 is 1 square is 1. So which is square root of 9, which is 3. So since AC is equal to BC, they are equidistant. Okay, let's look at the next one. Show that an isosceles right triangle is formed by the following points: A 0 7 10, B minus 1 6 6, C is minus 4 9 6. Now isosceles right angle triangle means what? See, basically you will have a hypotenuse in a right angle triangle. Now that will never be equal to the any of the other two sides. That means this side and this side should be equal since it is isosceles, right? Okay. And how do we prove that this is 90 degree? So we'll take the reverse of Pythagoras theorem. So let's say we don't know which one is A, which one is B, which one is C. So let's you know randomly take ABC. I just want to explain something. AB square plus BC square is equal to AC square. If this is true, then it is a right angle triangle. So to prove, we have to do two things. One is AB equal to BC, and the second is AB square plus BC square is equal to AC square. Now, the point is we don't know whether this is AB or whether this is AB or whether this is AB. So, which two points forms the hypotenuse, we don't know. So, let's figure out the distances between all the three. So, AB would be square root of minus 1 square is 1 plus 6 minus 7 is 1 square is 1 plus 6 minus 10 is minus 4 square is 16, which is square root of 18, which is we can leave it as this itself. Okay, what about BC? Now if we look at BC, minus 4 plus 1 is minus 3, 9 plus 9 minus 6 is 3 square is 9 plus 6 minus 6 is 0. So 0, which is equal to square root of 18, right? So luckily for us, AB is equal to BC. Now let's figure out AC. So this is taken care of. Now AC would be square root of minus 4, 0, that is 16, plus 9 minus 7 is 2, square is 4, plus 6 minus 10 is minus 4, 16, which gives us 36, which is equal to 6. Or what we can do is leave it as root 36. Now let's see. Um, we have root 36 square is equal to root 18 square plus root 18 square, which is 18 plus 18 and 36, right? So this condition is also satisfied. So therefore, the points form a isosceles right angle triangle. Okay, let's look at the next one. Show that A equal to I plus 2j plus 3k. B is equal to minus I minus 2j plus minus k. C is equal to 2i plus 3j plus 2k. D is equal to 4i plus 7j plus 6k are the position vectors of a parallelogram. Now, to prove that this forms a parallelogram, what do we have to do? We have to show that opposite sides are equal and the diagonals are unequal, right? So let's say this is the parallelogram. So here this will be equal to this will be equal to this, and this would not be equal. Yes, the diagonals will not be equal. This is shorter than this. Of course, remember, if you are talking of a rectangle, in a way we can say this is also a parallelogram, but then it has a specific name called rectangle. Okay, now let's do this. Now, this can be written as the in terms of coordinates, we can write it as 1, 2, 3. So 1, 2, 3. B can be written as minus 1, minus 2, minus 1, minus 1, minus 2, minus 1. C will be 2, 3, 2. D is 4, 7, 6. Okay. Now, AB would be 4 plus 16 plus 16, which is 16 to 32, 36, which is 6. This should not be brackets, it should be this. Okay, BC would be square root of 9 plus 25 plus 9, which is square root of 43. Okay, CD would be 4 plus 16 plus 16, which is root 36, which is 6. And similarly, AD is equal to 9 plus 25 plus 9, which is equal to root 43. So as we can see, AB is equal to CD and BC is equal to AD. So opposite sides are equal. AC equal to square root of 1 comma 1 comma 1. 1 plus 1 plus 1, which is square root of 3. Okay, and BD, these are the diagonals, would be 25 plus 81 plus 25, which is square root of 131. So AC is not equal to BD. Therefore, and we have shown the second condition also. So which means that ABCD is a parallelogram. Now, similar to this, if you are given four coordinates, right? You are given four coordinates. Um, or points, and if all sides are equal and the diagonals are equal, then it is a square. Now, to show that it is a rhombus, all sides are equal and the diagonals are not equal. If it is a parallelogram, as we have seen, opposite sides are equal and diagonals are not equal. Again, if it is a rectangle, we have to show, then opposite sides are equal. See, I'm writing opposite sides, but remember, we won't know which are the opposite sides. So you have to find all the distances between points and see whether two of them are equal and the other two are okay, and the diagonals are also equal. Okay, now what about if you are given three position vectors or points in terms of coordinates? Right here, there were four coordinates. Here we have three coordinates. Then in that case, what happens? For a equilateral triangle, all sides are equal. Isosceles triangle, any two sides are equal. Right angle triangle, for the square of one side is the sum of the squares of the other two sides, right? Okay, now let's do another problem. What we have to do is find the locus of a point equidistant from 2 points, 3, 4, 5, and -2, 1, comma 4. So let's say A is equal to 3, comma 4, comma 5, and B is equal to -2, 1, 4. And remember, locus of a point means as the point moves, its coordinates will change. So the set of all those coordinates uh, is called the locus. So let P x comma y comma z be a point, an arbitrary point on the locus. Now we are given that the condition that we are given is that it is equidistant from these 2 points. So PA is equal to P. So therefore, we know how to evaluate PA. So square root of x minus 3 square plus y minus 4 square plus z minus 5 square is equal to now PB. So x minus minus 2 is plus 2 square plus y minus 1 square plus z minus 4 square. Okay, if we square both the sides, we get x minus 3 square plus y minus 4 square plus z minus 5 square is equal to x plus 2 square plus y minus 1 square plus z minus 4 square. And here we get, what I'm going to do is x and x. I'm going to expand this. I'm going to expand this, and in the same step, I'm going to bring it to this side. So x square minus 6x plus 9 minus x square minus 4x minus 4 plus y square minus 8y plus 16 minus, I'm going to expand this and bring it to the other side. So minus y square plus 2y minus 1 plus z square minus 10z plus 25 minus z square. Again, I'm going to expand this and bring it to the other side. So minus z square plus 8z minus 16 equal to 0. Now here if you notice, x square minus x square, y square minus y square, z square minus z square. Okay, now let's simplify this. Minus 6x minus 4x minus 10x. Okay, minus 8y plus 2y is minus 6y. Okay, minus 10z plus 8z minus 2z. Okay, now let's focus on the constants. 9 minus 4 is 5. 5 plus 16 is 21, minus 1 is 20. 20 plus 25 is 45. 45 minus 16 is minus 29 equal to 0 plus. Okay. Now let's multiply the whole term, all the terms by minus 1. So 10x plus 6y plus 2z minus 29 equal to 0. So this represents the locus of a point equidistant from the given two points. Okay, let's do another one. 7. Now what we have to do is locus, we have to figure out the locus of the point such that the distance from x-axis is twice its distance from the yz plane. Okay, let this is the locus. So x comma y comma z be an any point or an arbitrary point on the locus, right? Okay, so distance of P from x-axis would be equal to, remember, since it is on the we are talking from distance from the x-axis, uh, it would be y square plus z square. Okay, similarly, distance of P from yz plane would be x. Remember, point on x-axis would be 0. X value will be 0. That's why square root of y square plus z square. Okay, now we are given that y square plus z square is equal to twice the distance from the yz plane. Okay, now it's just a question of simplifying it. So squaring both the sides, we get y square plus z square is equal to 4x square. We can leave it as it is, or what we can do is bring it to this side and then multiply it by minus 1. 4x square minus y square minus z square equal to 0. So that is the locus. Okay, I think that's enough for today. Bye for now.